Hi, welcome. In this video, we will solve problem maximum average subarray asked by companies like Microsoft, Amazon, and Google. Now let's check out this problem maximum average subarray 1. Okay, again, this is a very basic and fundamental problems on sliding window. So if you are going to learn a concept of sliding window, this will be the first problem that you will crack. Okay, let's understand this problem statement first. So you are given an integer array. So this is my integer array that is nums consisting of n elements. So there are n elements here and an integer k. Find the contiguous subarray. That means continuous subarray whose length is equal to k and that has a maximum average value. Maximum average value. What will be this maximum average value? So let me explain. So basically how we know how to calculate average. So that is average will be sum divided by k, right? Your like n elements, whatever it is. So here we need to find a maximum average value of a subarray. So subarray whose size is k, okay, whose length is k, okay. So if I want to find a maximum average, I need to find a maximum sum, right? Because k is constant, this will be constant. So basically, I need to find a maximum sum in the contiguous subarray. Okay. And then we need to return this value. Any answer with the calculation error less than 10 to the power minus 5 will be accepted. Okay. So like here you can see this is a contiguous array. And if I take a maximum sum of size k equals to 4, so it will be something like this. This will be the maximum sum, right? Of this size. You can check like if you are taking any other example, like if you are taking 50, okay, let's see, maybe this one is the maximum sum. So what we can do here, okay, once, first of all, how many subarray of size 4 we will get? One subarray will be this one, 112 minus 5 and 6. Then one subarray will be 12 minus 5, 6 and 15. Then one will be minus 5, 6, 50 and 3. These will be the subarrays of size with 4. And here if I'm taking more positive number, 12 minus 5 minus 6 and 50 will be the maximum sum of the subarray, right? So 12 minus 5 minus 6 plus 50, right? So it will be 6 minus 5, 11. That will be plus 1. So we will get 51 as a maximum sum. And if I divide 51 by 4, we will get 12.75. Okay, that is defined in the answer. Similarly, if we have only one single element, right? Size is also saying they are saying of one size. So what will be the maximum average? That the same element itself, right? So that's why it is 5. So now let's see. Now let's understand this problem more clearly. So I will take one example here. So suppose this is my array. Okay. And here I need to find the again maximum average. So the goal is the maximum average we need to find it. Okay, same task. Okay. And so maximum average of size 4. So again, for this question, for finding maximum average, what we need to find, that is the maximum sum. Okay. So what I will do, I will again check for all the possible subarrays first. Let's first of all understand the problem statement more clearly. Okay. This is our goal. Okay. So we will try to understand our problem statement more clearly. So one of the subarray of size k equals to 4 will start from here. Okay, and it will go to here. So 0 to 3. One subarray will be from 1 to 4. One subarray will be 2 to 5. Then 3 to 6. Then 4 to 7. And then 5 to 8. Can I see these will be my subarrays? Starting from 0 to 3, I will take the sum. If I am taking sum of subarray 1, that will be this subarray. Subarray 1, what will be the sum? 1 plus 4 plus 2 plus 10. Okay. That will give me a sum of 17. Okay, then I will take subarray 2. That will be 4 plus 2 plus 10 plus 23. Okay, that will give me a sum of 39. Then if I take subarray 3, so that will be 2 plus 10 plus 23 plus 3. That will be give me a sum of 38. Similarly, subarray 4 will be 10 plus 23 plus 3 plus 1, right? So what I will get as a sum? That is 37. Okay, then subarray 5, what I will get? 23 plus 3 plus 1 plus 0. What it will be? It will be around 27. Okay, subarray 6, that will be 3 plus 1 plus 0 plus 20. Okay, that will be 24. These will be my subarrays, all subarrays. From these subarrays, from all these subarrays, where I am getting the maximum sum. Okay, that is the maximum sum, 39. All right. So can I say this is the subarray where I am getting the maximum sum? Okay, this is my subarray. 4 plus 2 plus 10 plus 23. Yes, and that we need to figure out. Now we got the maximum sum, 39. Okay, we will divide by k, that is 4, and that will be our answer. Okay, or I can simply say that this is an answer. Okay. So now let's talk about the approaches, different approaches, what we can do here. So now one of the first basic, or I will say the most fundamental or brute force approach that can come to your mind, that will be, okay, let me mention it here. Okay, that will be approach 1 of brute force. Okay, so what you will do, you will generate all the possible subarrays. Okay, you will generate all possible subarrays, right? And then you will select the subarray of k, and then you will simply find the sum of it, right? And from these all sums, you will find out the maximum sum. Okay, and by this you will get the average, right? One of the basic, if I say, right, generate all the possible subarrays, select the subarray of size k, take the sum and find the maximum sum array, right? So there will be, like, here you can see, when I am generating all the possible subarrays, I will get these subarrays of size 4. Okay, and from this I need to find the maximum sum. So this will give me a time complexity of big O of n square, right? Why I'm saying big O of n square? Because like there will be some tweaks here and there, right? And then the eventual time complexity will be big O of n square. And that's why we are not going to lick on this brute force method. Okay. So now, okay, how we can optimize it? Can we optimize it from approach 1 to approach a further more optimization? Can we do it? Is it possible? Okay. So now let's see if I can do something right here. If I can simply change something from my brute force, from generating all possible subarrays, is there any chance that we can do it? Okay. Any hint? So one possibility is here that in, let's suppose, approach 2, instead of generating all possible subarrays, okay, generate subarrays or possible subarray of a specific size, of size k only, of this size, right? Like right now how I am generating it, and then again saying find the sum of, find the sum, from the sum find the maximum sum, okay, and then find the average, right? This will be approach 2. So if I am generating possible subarrays of size k, so these will be my subarrays, right? I will start from here, right? And I will move till here. Okay. Then I will start from here, then I will move from here. So let's quickly understand that your pointer, okay, suppose you are taking one j, okay, your pointer j is starting from here to here. So for this subarray, can I say my j pointer will start from 0 to what is this index 3? For this pointer, it will start from 1 to 4. For this, it will start from 2 to 5. For this, it will start from 3 to 6, 4 to 7, and 5 to 8. And that's what we are doing it. That's why we are doing it. Now, is there any method that how you can find out how many subarrays will be generated of this size? Like here you can see there are 6 subarrays that are getting generated. Okay. And what is n? N is here 9. N is 9, K is 4, and we are able to generate 6 subarrays. Is there anything, any formula that we can do it here? Okay. So yes, right. Number of subarrays you can directly tell. How? It will be n minus k plus 1. What is n? That is 9. K is 4. 9 minus 4 plus 1. And that will be your 6. And these will be your number of subarrays. Okay. So here you can directly say that how many subarrays of suppose if size given is n, array size k is given for the subarray size. So you will generate this much subarrays, right? So now you can see here you are simply again and again moving your pointer j from 0 to 3, then 1 to 4, then 2 to 5, 3 to 6, 4 to 7, 5 to 8, like this, right? So can I make a more generic term? Can I make a more generic term? Let me create a bar here. Can I make a more generic term here? Like, because these are constant values 0 to 3, 1 to 4. Can I come up with some any idea that can I make a more generic term? So now let's suppose, okay, this is your first subarray. So can I say that will be I equals to 0, first subarray, right? Then here I will be 1, 2, 3, 4, 5. So can we say your j basically start from here I and it will go till what is this? K is 4. Can I say it will be go till less than k? Right? But if I am putting less than k, it will be constant because here it is 4, 5, 6. So the better term will be here to say that I plus k. So can I say my general term will be j will always from starting from I and it will go till less than I plus k, right? So j will always start from I and it will go till less than I plus k. And we will do the sum again and again, again and again. We will find the sum. Okay. And when we are doing sum, we will find the maximum, right? If any of the sum is maximum, like here you can see, this is my maximum sum. I will update it and then I will take the average. Simple. Okay. So if I tell you the basic approach here, what we will do. So we will generate the number of subarrays, generate the number of subarray. How we will get it this? Simply by formula n minus k plus 1, right? Okay. And then we will find the sum of these generated subarrays. Okay. So one will be my simply my I pointer that will start from 0 to n minus k plus 1, right? So I need to simply run a I loop from that will start from 0 and it will go till n minus k plus 1 because from till here I need to generate all these subarrays, right? So now let's see. So what I will do, I will take a simple one loop that will be responsible for I equals to 0 to I less than n minus k plus 1. Okay. And inside it, okay, we will again always take sum from 0 and then we will start from j equals to I, whatever it is, and we will go till j less than I plus k. And in this, what we will do, we will take the sum of the elements, sum plus equals to ARR of G. And after this, what we will do, we will again calculate for maximum. Is it maximum or not? Okay, so we will compare. Okay, and then we will produce the result. Okay, but again, this will also come with some of the bit and time complexity. So we will discuss about it. First of all, let's see the code of, or we will see the code of all these approaches later. So let's discuss first of all the approaches. And if we have discussed this approach, let's quickly discuss the time complexity of it. So this for loop, so it will how many times this will run? Okay, so can I say like this is starting from 0, it is going till n minus k. So it will somehow run for n minus k time somehow, right? And inside it, how many times this loop is running? It is always starting from I, it is going till k. So can I say that it will somehow run for k times? Okay, so the upper loop is running for n minus k and the lower loop is running for k times. So it will be something around n minus nk, nk minus k square, right? And now if n is much greater than k, so can we ignore this k square term? Okay, so can we ignore this k square term? It will be nk. So the time complexity here will be big O of nk for this approach. Okay, but again, big O of nk again is not that optimized solution, right? Again we have k here, right? So again, you might expect TLE, right? Your interviewer can ask you to, can you further optimize it, right? This will can also give you time limit exceeded error. Again, you are not taking any space. So if I comment on space complexity, and that will space complexity will be constant. But yes, this is one of the approach that we have discussed. We will see the code of it. Now let's discuss a bit more optimized approach. Okay. So now let's discuss the approach 3 and let me copy the same elements. Now on approach 3, okay, what we are going to do, what we will do, we will apply constant sliding window technique. Constant sliding window technique. Why it is known as sliding window? Why we say constant sliding window? Okay, let me explain you. So the sliding window, constant sliding window, that there will be one subarray of fixed size. Okay, so subarray of fixed size, and we will move that subarray. We will move that subarray constantly right here, and then eventually we will get the result. Right, we will take this. Let me give you a bit of hint. Okay, so suppose this is your subarray. Okay, of size 4. Right, this is the subarray of size 4. If I'm taking the sum of my first 4 elements, right? First subarray, I will get 1 plus 4 plus 2 plus 10. Right, now what I will do, I will do a slide. Now you can see here the only new element that comes to in my subarray, that is 23, and one of the last element is removed, that is 1. Again I will slide it. Okay, so new element 3, last element removed 4, new element 1, last element removed 2, new element 0, last element removed 10, new element 20, last element removed 23. So this is how your constant subarray works. So what I am doing again, what is this approach all about? So I will calculate my first subarray. Okay, my first subarray. What is the subarray? That is 1 plus 4 plus 2 plus 10. What is the sum? That is 17. And now what I will do? I will add in my subarray the next element. Okay, next element. So 17 plus what is the next element? That is 23. Okay, and then after here adding it, I will subtract the previous element, or you can say the last element. Okay, So 17 plus 23 again in the same way. 17 plus 23 here minus I am subtracting 1. Or if I simply conclude this complete formula, it will be subarray plus next element subtracting previous element. Okay. So 17 adding next element 23 subtracting last element 1. Now can you do the sum of it, right? What you will get as a result, that will be 39, exactly same to your result, right? So you calculated first subarray and what you have done, you have added this next element and removed this previous element. Again let's see. Now let's take that subarray, right? This complete subarray with a sum of 39. Okay, and let's do the same thing, adding next element subtracting previous element. Sorry, subtracting, it should be subtracting sign. So subtracting previous element. So what will be the subarray? 39 adding new element 39 plus new element, that is will be 3, subtracting the last element. What I will get? I will subtract 4. Okay, what I will get as a result? 38. Can you see? Check it. This is exactly same as your subarray 3. Again let's see, right? If you take 38, okay, how much element you have added? 3. Let's add 1. 38 plus 1 and subtract the first one here, 2. What you will get? 37, again exactly to your same results, right? So this is your first subarray, second subarray, third subarray, fourth subarray, and you are getting all the complete results. So what I am saying, right, you need to calculate first subarray sum 1 plus 4 plus 2 plus 10. And then what you will do, you will add the element, okay, and you will subtract this element. Again you will move further, right? So you will get this much subarray, right? Because you add the element and you remove this element. Again you will move forward, you will add this element, you will subtract this element. What will be new subarray? It will be start from here to this one only. Again what you will do, you will add the new element and you will subtract this element, right? What you will get in the subarray, that will start from 10 and it will go till 1. Again what you will do, you will add this subarray and you will remove this element, right? What you will new subarray, that will start from 23 to 0. Again what you will do, you will add the new element, okay? You will add the new element and you will subtract this element. What you will get as a subarray, this complete 31020. And this is what we are saying. We don't need to calculate the sum again and again from starting from 0 to 4 that we were doing in the last approach. Taking all the sum from 0 to 3. We can use the same sum. We can add the next element and we can remove the previous element. We can add the next element, we can remove the previous element. Right? So if we simply do this, we will got the maximum and we can simply find maximum by k, we will get the answer. Okay. Now let's quickly check how we are going to proceed with this logic. So what I was saying, what I will do, I will take the first subarray sum. Okay, first subarray sum. How I will take it? So I will start from for loop. Okay, that will start from 0 to k. Okay, this will be my one sum, and inside it, let me put it here, right, this bracket. I will simply do a sum of the elements, simple. Okay, so array I. Okay, and I will compare with the maximum. Okay, like is it some maximum or not? And then what I will do, because I have already calculated first sum array, so can I say that I have started a sum from 0 to k. Now I need to start from k to n. And what I will do, okay, I will in my sum, okay, in my sum, I will add the next element. What will be the next element? Okay, that is the I. Okay, once you have added, it will be the I, and you will subtract the previous element I minus k. Okay, so what is this sum? Basically, this sum is coming from here because you got the sum. In the sum, now you are adding the next element. Okay, this is your exactly as we discussed, next element, previous element, and subtracting the previous element. And again here you will calculate is it maximum or not. You will get the result. So this will run for how many times? K times. Okay, and this will run from K to N times. So this is run for K times separately, complete separate. This is run from K to N times. So can I say if total N times, so it will run for N minus K. Okay. So I have something that is running for K times, then N minus K times. So what will be the time complexity of it? How many times this will run? N times, right? So the time complexity will be big O of N. And are we taking any extra space here? Are we taking any extra space? No, that is constant, big O of 1. So this is our final approach that you can simply apply. You will get the results. Now in the next video, let's check out the code implementation of the two approaches that we have discussed.